All right, so today we're going to be doing question 542.01 of matrices, right? So looking at this question, right, it says, given the m by n binary matrix called mat, return the distance of the nearest zero for each cell. The distance between two cells sharing a common edge is 1. So taking a look at our example 2, and now being given the instructions, I'm going to kind of explain what that means. So we have a matrix, right, or a graph or whatever you want to call it, and within it you have rows and columns, right? And within these rows and columns, taking a look, you have 0, 0, 0, right? That's for our first row. And then the second row, you have 0, 1, 0. That's your second row. And your third, you have 1, 1, 1. Cool. So now we know what's inside, but we want to know what we need to do to get the output of 0, 0, 0, 0, 1, 0, and 1, 2, 1. Taking a look at it without really reading the instructions, this value is very similar to this value. This value is very similar to this value. And this is very similar too. The only difference is this is a 2 and this is a 1. Why is that a 2? Well, what we're doing is we're starting at a specific point within the row and column and saying how many instances will it take if, being able moving up, down, left, and right to get to the closest 0. So let's say if we start here, top left row, right? And the value is 0. Well, we already are 0 by itself, so there's nowhere for us to go because we are equal to 0. And this basically follows us for the entirety of this row because they're all 0. Hence, your output for the first list will be 0, 0, 0. Now we go to the second row, right, where it's 0, 1, 0. Well, let's look at the first number, 0. 0 is already 0, so there's nowhere to go. 1. Well, 1 here, the reason why you have a 1 output is not because you have a 1 here. It's because it takes 1 movement to get to the closest 0. So given the ability to move left, right, up, or down, well, this 1 could just move 1 value to the left and it'll be equal to 0. That's the closest amount of movements we need to get to a 0. Hence, we're going to put 1 there, right? And if we go to the value right after that, which is 0, like I mentioned again, if 0 is already 0, there's no movements, so just set it equal to 0. Now, for the last row, this is where things get a little bit more interesting, right? Taking a look at bottom left corner, this 1 right here, well, the closest, or not the closest, but the shortest amount of steps to get to a 0 is 1 because all we have to do is move up 1, right? And if we take a look at the right, vice versa, all we have to do is move up 1. But what about the 1 in the middle? Well, we can't go down because we're out of rooms within the matrix. We can't go left or right because left is equal to 1, right is equal to 1. And after that, there's no more values in the matrix. So all we could do is go up. And if we go up, right, it's not a 0, it's a 1. So what we're going to do is add to the count and be like, okay, well, we moved up 1, and this still isn't equal to 0. So if that's still not equal to 0, then continue. So we're going to continue moving. We're going to move up 1 again, and now it's equal to 0, right? So now because it's equal to 0, and it took 2 movements, we're going to set this value equal to 2. Hence, why the output is 1, 2, 1, because it takes 2 movements to get to the closest 0. So now as we have an idea of why we're getting this output, all we need to do is be able to write this in code. How are we going to do that? Well, looking at this question, what I'm going to tell you is that we're going to be using a queue, right? We're going to be using a queue, and we're going to be using some form of nested for loops because we are working with a matrix. And if we're talking about rows and columns, one for loop needs to represent the row and one for loop needs to represent the column. And within both of those nested loops, we are able to do the code that needs to be done in order to achieve our result. So, like I mentioned, we're going to need our rows and columns. But first, we're actually going to make height and width. So we're going to make a height variable. We're going to get a width variable. The height and width of mat, right, or matrix. And how do we get the height and the width? Well, all we need to do is do length of mat, right? Length of mat. And we're going to leave height by it is. And for the width, all we're going to do is just add index 0. So now, this is going to tell us how many rows there are. This is going to tell us how many columns there are. And then we're just going to create a simple queue. Beautiful. All right. Now as we kind of have our variables, what we're going to do is do that nested for loop like I mentioned. So for I in range of height, the variable we just created, right? And then we're also going to need to loop through width. So for j in range of width, beautiful. Right, do that. So this is going to loop through every grid, right? And I is going to represent our row, and comma, and j is going to be our column. There you go. All right. So what are we going to do within this code? Well, the first thing we're going to do is we are going to check if the value that we're on currently within the matrix or mat is 0. Why are we going to do this? Well, what we're going to do is we're going to loop through the entirety, which is what this nested for loop's doing. It's going through the entirety of here. And we are checking if the value that we're on is going to be equal to 0. And if it is, we're going to add that value into our queue. We're going to queue.append the row and column. If not, for instance, if the value is 1, we're actually going to change that 1 into a pound symbol, right? Or it could be anything you really want it to be, but in this instance, I'm going to make it a pound symbol because we want to have an indicator, right? What we're going to do is we're going to make the pound sign to mark out that hasn't been touched yet, like those values haven't been met. And because those values haven't been met, we need to calculate the distance that still needs to be made, like how far from how far is the value we're from to 0. So how that's going to look is we're going to go and check if mat at index I and j are equal to 0, right? Then we're going to add values into our queue. There you go. And we are going to add I and j. Beautiful. So like I mentioned, we're going to do we're going to append. So if the value you are on is 0, we add it to queue. There you go. And then after that, we are going to go and make a else statement and do mat at index I and j equals pound sign. Beautiful. All right. So now as we have that, everything's all set. How this is going to look is coming here, right? We're basically looping through the entirety of this matrix, and if a value is 0, we're going to add it to the queue, the row and column, right? And if it's not, then we're going to just set it equal to pound sign, which basically will look like this, right? Like this, and like this. There you go. Right? And then do another for loop. This time we're going to loop through every position within the queue that we just made. So for row and column in queue, beautiful. So this is a loop through every position stored in queue. There you go. All right. So we're going to make another loop within here. And this time, this loop is going to be doing is actually it's going to be doing the up and down and the left and right. Because remember how I said at our starting point, we need to be able to look, go up, go down, go left and right to see if the values next to wherever we're at are equal to 0, right? And the way we do that is by actually writing these numbers out. So we're going to do 1, 0, and then we're going to do a comma, and then we're going to do -1, 0. I'm going to tell you what each one of these means in just a second after I type them out. 0, 1, comma, and 0, comma, -1. Okay, there you go. So, like I mentioned, this is going up, down, left, and right. The 1, 0 is going to represent down. -1, 0 is going to represent up. 0, 1 is going to represent right, and 0, negative 1 is going to represent left. Beautiful. So now as we kind of have an idea of what this loop is doing, and I'm actually going to write it down for simplicity's sake. So this loop, down, left, and right from the value we are currently on in Q. There you go. Okay. And then we're going to actually make variables, one called new row and one called new column. There you go. And what we're going to do is actually grab the row plus dx, and vice versa. We're going to grab the column plus dy, and this is going to be our new rows and new columns, right? And then we're going to create an if statement after that, or our edge case, really saying, are we still inside the grid? Because we want to make sure that we're still in the grid when moving left, right, up, and down. This is really important, right? Is the cell unvisited, or are we equal to a pound sign? Because if we're equal to a pound sign, then it's not a 0, and we want to continue. So how are we going to write that code? Well, we're going to create an if statement first, right? Because this is edge case if, and then 0 is less than or equal to new row. If new row is less than our height, and 0 is less than or equal to new row, and our new row is less than width, and our matrix at index no row and no column, right, equal pound sign. Nope. There you go. Right? If all of these meet, these requirements are met, then what we're going to do is we're going to grab our matrix at index new row and new column, and we're going to set this equal to our matrix and row and column plus 1. There you go. And we're going to add this to our queue, our new row and new column. Perfect. And then after all that is said and done, all I need to do is return mat, and we should be straight. So let's just take a look at the code one more time. You have your height, you have your width. You grab this by grabbing the length of the matrix. Height is just the length of the matrix. Width is the length of the matrix at index 0. And we created a queue for later, right? And then looking at the nested for loop, we loop through every grid. I is the row and j is the column. Within this nested for loop, we have an if statement just saying if the value you're on is 0, we add it to the queue, right? So if we're equal to 0, add it to the queue. Else, we're actually going to set that value within the row and column as a pound sign, right? This pound sign is going to be used to help identify and strain out and count how many instances, because those are going to be our starting points, right? So looping through every position within our queue, right? So for row and column in queue, because remind that when we were adding values in queue, we added them as I and j, row and column, right? Perfect. So when looping through the queue, you are going to go and do another for loop, this time with the values 1, 0, negative 1, 0, 0, and 1, and 0, negative 1. This represents up, down, left, and right. So this is going up, down, left, and right of whatever position we're currently in. And then we're actually going to set variables to that, to the current position we're in, plus the row and plus the column, right? So we have our updated values. And with those updated values, we create this edge case base saying if 0 is less than or equal to our new row, and if our new row is less than the height, right? And 0 is less than or equal to the new row, and new row is less than width. And basically, if the matrix at index new row and new column equals pound sign. So to kind of simplify that, because that sounds like a whole lot of mumbo jumbo, so it's asking, are we still inside of the grid? Is the cell unvisited, or are we equal to a pound sign, right? So if we're inside the grid, if the cell has been unvisited, or we're equal to a pound sign, then we do the code within, which all that's doing is basically grabbing mat or matrix at the row and column of new row and new column and setting that equal to the mat of the original row and column plus 1 right? Because we're adding a +1. Remember, we're moving up, down, left, or right, or wherever we may be going. And then within the queue, right, we are actually appending the new row and new column. So queue is updating consistently. Keep in mind that we put these inside these little parentheses, and we return mat or our matrix because we were updating matrix consistently so that we actually get the output like this. So if I was to give this a run, let's make sure everything is working perfectly, and it's not. I am lying to you. Why is this? Well, we actually are getting a £sign instead of a 1 here. Why may that be? Let's see. Case 2, which is this the same thing? Huh. Okay. Yeah. So we're keeping the zeros, but any value that's not, we're screwing up. Okay. Wait a minute. No, I lied to you. The hiccup indeed, my friend. Hiccup indeed. Let us take a look at the code to make sure we are doing everything right. 0 and IJ. Else, this looks good. Q. This should be right. We're gonna get there. I just gotta make sure I'm checking every line. We're looking good. I'm low-key kind of wondering what seems to be the issue here. Oh, hold up. Because new row is here, this is new column. Okay, that was an issue because it's a completely different variable. That's wrong. Oh, there you go. All right, hold on. We're not out of the clear yet. Let's submit it. There you go. Okay, we were a little bit stuck. Sorry for the delay. I did mention that this was equal to new row, not new column. That was bad because this was basically we have if we're still inside the grid, and then if the cell's unvisited. But this was for the if the cell's unvisited, and we needed to make sure that this was equal to new column, not new row. So that was just a typo mistake, or not even a typo. That was a genuine mismatch of the variables. And the return mat was just outside, or was inside the nested for loop. We needed to have it outside. So we kind of knew that was an issue beforehand. This, however, was the thing that we needed to find, and it's accepted. Beautiful. So to take away from this, this is a Q question, right? We have a nested for loop within here, actually 2 of them. And we have starting points. The starting points are going to be our hashtags, and we're moving up, down, left, and right, seeing if those values are equal to 0. If they're not, we continue into the queue, appending them, and kind of having this constant cycle. And yeah.